Hello, my name is Everly Adams, and I'm in Mr. Lang's Computer Science and Software Engineering course. And for the past few weeks, we have been working in our teams to program our Sphero bolts. So exactly what a Sphero bolt is, it's just a little robot ball that you can make it move by programming it. But what we did with our Sphero bolts was we programmed it to go through a maze. So if I pull up my video here, I'm not going to play it through, but you can just see that this is just clips of the maze that it programmed through. So when we were programming our bolts, we used GitHub to store all of our local changes and commits, and eventually pushed it up to the cloud. So if I go over here to my history, you can see all of the commits that I have made over the past few weeks. But the first commit I'm going to show you is my start and say start. This code initially just makes the bolt say start, and on the screen in the video you should see that it says start. So if I go back here and you listen closely, it should start should pop up here, and you should be able to hear start. Start. So I definitely heard it. I don't know if you could see it right there because there was a little bit of a glare, but that is initially what the code does. Now the second checkpoint that we did in our maze was the green checkpoint, and the green checkpoint is this is this checkpoint up here. So if I go over here, all we did was we just set the initial speed to 60. We made it go for 2.7 seconds, which is what an await delay means. It's basically how long you're going to program the bolt to go that direction for. And then we made it stop at the green checkpoint, and we made its LEDs turn green. With that, we just set the red to 0, blue to 0, and green to 255. So, you see if I play it, it should go over here and stop. So yes, that did turn green. And so, if I go back to the video, this is our next checkpoint. I believe this is called sound checkpoint 1. And you can see that some of the commits don't have an actual name, they just have the date. Those commits are just at the end of the hour when we ran out of time. We didn't actually finish a checkpoint, but we saved our progress by naming it the date. So if I go to sound checkpoint 1 and check out this commit, I believe that sound checkpoint 1, where is it? Sound checkpoint 1 is right here, and all we did was we just set the speed to 63. For this, we had a bit of a trouble trying to find the exact speed because if we kept it the same speed over here at 60, we couldn't exactly get the timing down, but we found that if we have it at 63 and a wait delay at 2.5, it would work pretty well. So basically what this commit does, the set speed makes it go 63, a wait delay makes it go 2.5, and then let me just show you this. Should we over here? So the other part of the code in the video, I showed you the code that gets you to here, but what we needed to do was we needed to make it go right 90 degrees and forward just a little bit more. So what we did was we did a plus 90 to make it turn 90 degrees, and then we set the speed to 49, and we had it go just for a little bit, so we did it to 2.2. And then what that noise you heard was there, we made the sound an animal sound. So what we did was we just did an await sound, animal, monkey, and then play. There's many sound noises you can choose from, but we just found that the monkey one was going to be the easiest for us to play. Okay, so the next checkpoint we did was we did a red checkpoint, and this is just like the green checkpoint, but instead of it being green, we did the LEDs to red. So we made it doing a weight roll. We made it turn 90 degrees, and then we set the speed to 28 for 1 second. And then you can see here, this means that the LEDs is going to turn red. So if I play that, you should be able to see it. It's going to turn, go straight, and then the LEDs is going to turn red. So yes, this part of my code ran really well, but you can see as we get to the end, we did not finish it, so that just shows you how difficult this maze was. But the next sound checkpoint is our next checkpoint. So if I go to sound checkpoint 2, what we did was we made it turn 90 degrees, go straight, and then turn 90 degrees again. And for this time we chose a robot voice saying enemy detected. So if I play it,
and we went
so if you heard that, the bolt did say enemy detected. Now we're getting to the end of the code where I'm pretty sure this these checkpoints did not run smoothly. So if I go, our next checkpoint is purple. And so what we did was we set the speed to 37. If you're wondering what these red things are, these are just what we changed. So originally it was at 4.55, but we found that that did not work smoothly, so we changed it to 4.65. We set the speed to 0, we did an await delay to 1.5. We did an await delay down here. We changed it from 0.75 to 1.05. We stopped it just for a quick second, and then we did a wait delay, and we did a roll plus 60 degrees. We set the speed to 27 for 1.9 seconds.
Oh my gosh.
So there you go, you can see that it went straight, did a 90-degree turn, and then a 60-degree turn. So you can see that the last few bits of our code they don't have the actual checkpoint name because we did not finish them. So I'm just going to show you bits of code that we did not complete. So down here after the purple checkpoint, we did an await roll for negative 95 degrees, 29 set speed, and 3.4 seconds. And then we made it turn left 90 degrees, which would be a negative 90. Changed the speed from 29 to 28 for 3 seconds. And then at the next sound checkpoint, we made it doing a lion sound. So if I show you that, it's gonna be up here.
Because we're gonna need one.
Okay. So that video did not capture that because it stopped working because it got caught on the carpet, and that happened many times. Since the carpet is uneven, our bolt sometimes would get stuck in the carpet and cause our code to malfunction. But if this did work, I believe the bolt would have gone straight, turn 90 degrees, go for 3 seconds, and then play a animal sound. You can see if I play our video back till the end and I stop it.
Start.
If I make it go back here, you can see that we did have a little bit left of the maze that we did not finish, but I believed if we had a little bit more time to work on it, we could have completed it. Okay, now that I've shown you all of my GitHub commits, I'm going to show you where we actually wrote the code to play. So this is an application called Sphero edu. So what this is just a text editor where you can write the code and then you can connect your Sphero bolt and run it. So this is just all of the code that I just showed you put together. You can see that we did not finish the code, as I said, but that is not only the text editor that we used. So that's very to you. But if I go over to this application called Atom, this is where we pasted all of the code and we saved it. We would do a Control S and we saved it to our GitHub, and finally we pushed it to the cloud. Okay, that is all I'm going to show you for this vlog, but if you have any more questions or you want to know more about what we do in Mr. Lang's Computer Science and Software Engineering course, you can watch any of my other vlogs. Thank you for watching.